Morning, everyone. So for this session today, what I wanted is kind of give you a brief introduction for fraud detection, also how you can run it in real time. Obviously, there are some challenges and solutions, obviously, for these type of problems. When you hear fraud detection, you assume basically it's just one single transaction in isolation. So for example, when you try to do online payment, for example, or you pay for a product or online shopping and so on, you assume it's just one single transaction or just one bank account or one credit card is involved in this process. And obviously, that's not the case. So even, for example, for small applications where you try to predict, so when I say predict, I mean using machine learning models to do fraud detection. It becomes really hard when you take it into production. So this is the whole idea of this talk, to focus on how you can take your application as it stands. It doesn't matter if it's fraud detection or not, and take it into production. So how do you put it in production? How do you make sure it doesn't fail? And if it fails, what are the alternatives? And obviously, with all aspects involved in terms of your data, for example, or your hardware, or your compute. So all these aspects affect how you actually run it. So even if you don't want to use machine learning as well, so the goal for today's session is just to focus on the real-time stream processing and how you can achieve it. So my name is Fawaz Ghali. I am the head of developer relations at Hazelcast company, which is for real-time stream processing. If you heard of Hazelcast before, if not, it's you know a real-time stream processing platform built on top of Java virtual machine. It's open source, so you should be able to replicate my work today or my demo today. So you should be able to download this jar file if you're using Java, for example, and run exactly the same steps so you can see how it works. And obviously, if you still have any questions about these topics or if you want to discuss your use case, I don't know your background, so I don't know exactly what you're working on, obviously. Feel free to reach out online so we can have this discussion. So I came from a city, and this city has these people. Anyone recognize these people on the screen? Yes, that's correct. So yeah, I'm based in Liverpool in the UK. So I took flight yesterday. I'm flying back tomorrow. Sorry, today actually. And I wanted just to highlight this on the screens, just simply because I wanted to say when you hear streaming, you assume it's something has to do with music or TV, and even if that's the case, it's not only streaming for music or movies and TV shows, it's more than that. So any data can be streamed, and this is exactly what we're trying to do here. Obviously, with the use case for stream processing for fraud detection, we're targeting very specific niche area. And if you want to have this discussion with your boss, basically about how you can achieve it, most people assume that you can basically take exact setup you have, same model or same application, and essentially try it out, test it, and then run it into production, and you should expect some results. But that's not the case. It works fine if you have, like, I don't know, small application with a few hundred records or a few hundred events and you want to do it, that's fine. And if you're coming from data science background, you want to try out some machine learning models, that's also fine. But if you want to take it into production, this is like a roller coaster, right? So it involves so many elements. So you want to not only handle the ones on the screen, obviously, but this is kind of like the roller coaster you will ride in order to get the results expected. And even like if you manage to do or run through this roller coaster, results are usually not confirmed, which means that even if your model runs into test or development, it doesn't guarantee running into deployments, which means you need to adjust it on the fly. So packaging your application, how do you can deploy it in terms of scaling? Do you scale it up or down? If I ask you now how many transactions or how many records you handle or you process in your application, you probably have average number. So maybe 1,000 events per day or 20,000 events per hour. I don't know. but you should have some kind of number, right? So this number refers to the average. So which means for this application X, you have Y number of transactions or events, and it works just fine, right? If it happens and you have 10 times more, which means you moved from 20K to 200K transactions or events, how's it gonna work? How do you scale it? And most importantly, do you just add more hardware? And if the answer is yes, when do you scale it back? So for example, some events you might heard of like Black Friday, Christmas, online shopping discounts, and so on. So if you have an online store which handles 1,000 transactions per day, for example, and you want to run a promotion, and for some reasons you get 100 times more, so which means you got spike in your data. So how do you process these spikes? How do you make sure it doesn't fail? Companies have dealt with these type of situations before, and they have done some research as well. So if you're coming from a research background, you probably heard of these studies where it takes roughly around 100 milliseconds, which is like 1/10 of a second, for a user to switch between two apps if the first app is not responsive. So if you try to open your mobile now for whatever app you want and you didn't get a response and you just moved to a different app for the same functionality, it takes about 1/10 of a second to switch between these two apps. So this is kind of like pretty fast. And this is exactly what we want to focus on today, is how do we get it to that part? How do we scale up? And obviously you want to save cost, right? So you should be able to scale down. So when you finish from these spikes, you should be able to roll back to your average transactions or events, and then continue as you go along. Obviously you need to monitor it. So now if I ask you again, different type of question. So are you able to monitor your application in real time? So do you know what's going on in your memory? How many, processes are, busy, or how much memory you're consuming? Do you know your heap size, your Java heap size? Do you know what's going on in your Java virtual machine in running time? So all these questions, you should be able to handle it. And I will explain why this is important. And at some point, these applications need to be switched on and off, which means you might be switching data centers. So if it is running in Norway, for example, and you want to run a data center in the UK, you want to do switch between these data centers, and at the same time, you don't want your application to stall or pause. So that's where deployment. And for advanced use cases where you have some machine learning running in real time, this can happen not because of data centers, but because they switch between different machine learning model in real time. So if it happens and you access your profile on your favorite social network, doesn't matter which social network, on your mobile, and at the same time you use your laptop or different machine, you will get different feed. So that's what's going on here. So even it is you who is logged in and you're looking at your feed, but you get different results simply because they're running different algorithms in real time to measure your internet connection, your bandwidth, your location, for example, and so many factors. So what is real time? This is very important to understand. You might not have these use cases, but as a work, right? As a developer or as a data scientist, but definitely use it in everyday life. So anyone can guess how long it can take for an eye to blink? Second? Come again? Yep. So it takes sub milliseconds, right? So we're talking about 1/3 of a second, so roughly around 350, depends how old and so on, so many factors. But if you clap for hands, for example, or if you have digital SLR, all these actions are pretty fast, which means they are running in sub milliseconds, and they are everywhere. So you see it in bank and finance, as you will see it in demo today. So today demo is mainly for fraud detection and online payment. But also you see it in smart devices. So if you have some smart devices at your home, or some smart cars, and all these type of smart devices or IoT devices, they use real time. Hospitals, for example, medical use cases, football or sports, they use real-time stream processing or even machine learning as well, which is kind of important. And this is where things can make or break. So we're moving from 4 nines, which is 99.99, to 5 nines. So we want the application to run in 5 nines, so 99.999%. So this is the difference between normal applications and real-time applications. And if we just take a simple application, so let's just say we all have a debit or credit card, doesn't matter, and you swipe this card, right? Whether you're trying to withdraw some money, for example, or you're trying to make a payment. So this request is sent to your bank. Obviously, there are so many elements and parties involved, but let's just say it's a simple process. You swipe your card, it goes to your bank. The bank checks your PIN code, for example, all other details, and send requests back. So whether it give you money or not, give you loan or not, and so on. So there is an SLA. So there is a time limit or time frame or time window, whatever you want to call it, on this transaction, right? And between where you're located, so if I am in this place, for example, and there is a machine card outside, I swipe my card, this request goes to my bank in the UK. Obviously, there are elements which you can't change, right? You can't adjust or configure or anything like this. Mainly network hoops. So where is this request or how this request is going to my bank? Input, output, for example, you're reading, writing to your data center, and so many factors involved, and these you can't change. If you want to write an application to handle this type of transactions, there are elements you can change. What you can change is very small time window. So this is where you need to take the advantage of latency. So if you work with this type of applications, but if you remember 4 nines and 5 nines, we're talking about latency. So basically the delay between sending the request and receiving it back. Some elements are hardware, which we can't control. Other elements related to your application, we can and we should control. So this type of SLAs varies from a bank to bank. So it could be, I don't know, on average, obviously, maybe 40, 50 milliseconds. Some banks handle it or have SLA of 20 milliseconds. So you should get back, or you should get a response in 20 milliseconds and so on. Or it can go to up 100 milliseconds. But still, we're talking about some milliseconds here. And as you can see, we want to apply so many operations in this very small time window. So we want to ingest the data. We want to read the card details. We want to enrich it. So we want to add context to it. Obviously, we need to do some kind of transformation. So if you're coming from data science or normalization, filtering, and so on, then we need to predict if it is you who's using the card or not, and finally send this card. So in order to actually see what is involved, apologies if the font size is small here. So it's kind of like a JSON format. It's text, basically. So we get some properties or features for this transaction, right? So on the screen here, if you don't see it, it's just number, for example. You have account. You have some kind of where is the merchant, where you're using your card, obviously device, if you're using your mobile or whatever, or ATM. Now, if you want to enrich it, we want to know more about this. And usually it's not related to the transaction. It's kind of like looking at your, I don't know, gender, for example, or looking at how much you spend. You're looking at your credit score. And for example, real-time features, these things change over time. So whatever you can describe as limited features, this will change over time. So you move from limited features for a product or an event to unlimited or online store feature. Now the transformation, as I mentioned, you do some kind of feature engineering to determine which features you want to use. Obviously, with run normalizations and filtering, all these aspects happen in real time. And also the prediction. This is where you have your machine learning model, right? So this is what you trained, what you validated, and you want to run it and deploy it in real time. And finally, we send the yes or no. So whether to have acceptance or not. Keep in mind, if I say accept, I mean true. If I say decline, it's a false. But there are other factors. So for example, false positive also we need to handle. Anyone can guess what is false positive for fraud detection? So false positive me. Did you want to say? No. Come again, sorry. Yeah. So that's actually correct. So essentially, it's you who is using your card, but your bank, for whatever reason, decide to decline because they, their algorithm or their application, or they say basically we have to decline because it's fraudulent activity. So it is true that you're using the card, but if, for example, for whatever reason, it got declined, this is where things can go wrong for the bank as well. So remember, banks usually make money when you do transactions, right? So if your bank declined your card, essentially it's affecting them as well, because that's where their profit goes less, because this transaction, they don't have commission on it, obviously. And if you have multiple bank accounts, you definitely have preference. So you say, I want to use this bank account over this bank account simply because I have better user experience. And if you don't think this is a problem, some numbers, some banks loses over $100 million per year because of false positives. So not only you need to predict fraud activities, but also you need to minimize the false positive in this case. So you want to make sure to validate it when it is true. So that's cool. So if you want just to say what we're trying to achieve in terms of process, I mentioned real time, which is great. But if I want to explain what real time stream processing is, it means you have to process the transaction, or you have to process your data before you store it into database or file system. Let me repeat it again. You want to process your data before you store it into database. So I think 90% of us here do it the other way around. So usually you have some data, you ingest it, you read it, you store it into database, and then you read it back, you load it to your application, and you say from X1 to 100, give me the average or give me some or whatever. So you do the analysis or processing after you store it, and we don't want to do this. We want to process the data before we store it into database. Why? Because we're trying to avoid latency, right? We want to minimize latency and provide quicker responses. Now, this is just half of the story. It's not the full story. We still need to access data stored somewhere at the same time. Remember when I swipe my card? So when I swap my card, this is real-time data. So the actual data comes from my card, from my name, and so on. But there are so many factors involved in this process. And these factors or elements are stored somewhere. So for example, GPS coordinates. So now I'm based in, or I am located now in Oslo, for example. So if someone is using my card back in the UK, at this moment, I should know now, right? So some banks might use GPS coordinates, for example, for this case. So GPS coordinates are not real time. Obviously, it's updated in real time, but for example, locations are stored somewhere. Transaction history is not real time. This is where they check your last week or last month and so on. Weather forecast. Someone asked me, why do we need weather data in order to do fraud detection? The answer is simple. So it depends on which city you're located, what is the weather or temperature, and how does it compare to where you have your card. And so all these elements come into place, and you want to combine. So which means you end up with a very complex structure because you handle data in different time frame. Now we're talking about transactions which happen in like not 20,000 or 200,000. We're talking about millions of transactions or billion of transactions. And the goal here is to move from handling or finding the needle, basically. So we want to be able to provide alerts. Obviously, you want to know If someone is using card now, you don't want to wait till tomorrow or afternoon, for example, to know. Your bank might need to know a trend, so how you're doing in terms of previous transactions, or we want to do some kind of enrichment. So your machine learning model, for example, or your algorithm for fraud detection still needs some enrichment, as I showed before. This enrichment comes from different places, and we want to actually proceed into finding a best way to actually have multiple inputs at the same time. Again, most of applications I've seen, they have only one single source. So this is where you read your data from database or from Kafka, whatever, and then you process it. So in this type of applications for stream processing at high scale, we want to handle data from multiple multiple inputs. Now, obviously, there are so many tools to do this type of work. So on this screen, you see 12 sections. So you might heard of some of these or all of them, or you might heard of none of them. Essentially, it boils down if you want to use open source version or if you want to use managed service, so you have it on the cloud or in between, hybrid. And there are so many elements involved. So first is how you actually capture your data. How do you transform it? For example, how you do operationalization, and then how you can actually do analytics. In most cases, you will end up using multiple tools, which means it adds up to your development cost because you have to spend more time, maintenance cost. So all these packages you want to actually maintain, update, and so on. And in order just to simplify it, it's nice to see it in this way, but I like to see it in simplified way because after all, simplicity is key in these type of applications. Like I mentioned, we were talking about mission critical applications, right? So where there is no big room for error. So we want to minimize any error. So we can simply look at it in two different areas, right? So we have real-time data. This real-time data could be coming from Kafka streams, whatever transportation comes in from. These tools are pretty fast in terms of real-time data, and we also want to access some contextual data, some data stored in file system or database, for example. And this is kind of like, you want one tool from left and one tool from right, and essentially you end up with the same application I will show you today, but you will have to spend more time, obviously. And there is also a learning curve, so how long it takes you to get up to speed with this. So the solution is kind of like I want to focus on is built on the Hazelcast platform. So the platform, if you haven't heard of this platform, essentially it's built on Java virtual machine, it's open source, so you should be able to download it. And if you're coming from data science background, you can use SQL if you don't want to learn a programming language. If you want to use some advanced features, there are so many clients, so you can connect it to Java. I will show you how you do it. C++, .NET, Python, for example, if you want to have machine learning model. And essentially, you need to import or ingest data from one side. And remember, we will going to use multiple sources, so we will check orders or fraud activities, and then we will check IoT devices involved, GPS coordinates, weather forecast, all these elements comes into place. And essentially, once you have data ingested, you have two options here. So you can either do it as stream processing. So this is one part of the story, or it depends on the use case, obviously. In most cases, mission critical applications require to use both, where you need to load some contextual data from your database and file system. It doesn't matter which database or file system you're using. Essentially, you load the data into memory in order to allow faster access. Once you do the stream processing, normalization, and machine learning, you can simply output your results into some kind of sinks. Sinks could be you can send it to Kafka, for example, or you send it to WebSocket, or even store it into database, and so on. Again, if you look at your application, it doesn't have to be exactly fraud detection or stream processing. And now, if your boss comes tomorrow and say, hey, I want your application, instead of saving to database, I want you to send data to WebSockets. for example. You spend few days or few weeks, it depends, I don't know, to do this job. Again, if they come back and said, hey, I want to write an API, for example, to send it to some kind of microservices, again, you spend few days. So it's very important, whatever solution you use, to focus on how you can export your data. So to look at it before we move to the demo, here we have a Kafka topic. How many of you heard of Kafka? Come again? Yeah, no, yeah. So pretty much everyone knows here what Kafka is. So this will save us some time. Essentially, you have a messaging coming into your application, and if you want to process this type of events, you want to kind of like attach it to some kind of models. I'm using Python because I'm using machine learning. It doesn't have to be Python. It could be anything. So this is where you import or ingest your data into Kafka, into your application, and from there you process it. I've seen it so many applications get it wrong simply because they store it into database and then they load it back. You don't need it even if you don't want latency or you don't want to minimize latency. You should be able to process it in real time and as well enrich it, right? So this is where the main source is. You want to enrich the data coming from Kafka. So what does it mean if I tell you I have order with like X amount and X value? So it's not full story. You don't actually know if it is a fraud activities or not. You still need to import multiple elements, multiple features into the application. So once you actually use multiple machine learning model, now you can proceed to create some kind of Kafka topic piece or different topic, but in this case you have your results integrated. As infrastructure, what we're looking at is kind of like microservices, right? So you have multiple topics working with multiple microservices. Remember, so there is one microservice for transactions history, for GPS coordinates, for weather forecast, and so on. So all these have different topics are working at the same time. And obviously, we want to access more context. We want to add more context to the application, and this is where the application itself should have some kind of data objects. So this is not coming from Kafka. Now, how does it look? Because it's very important to see the virtual machine for Python for your machine learning model. As you can see here, you have the same data, and you should also be able to read it once. You shouldn't read data multiple times from Kafka because this will add more, performance. Less performance and more execution time. So we want to minimize it. So we want to read once, have multiple models. So you ingest it one and use multiple Python models and different scores, and at the same time ingest it to multiple outputs or things. I want to actually move to the Kafka and the demo, but this is the difference between batch processing and stream processing in real time. Essentially, how many models and scores you do in order to do the enrichment. So in some cases, you have a score of 1, which has one model, and in other cases, you have multiple models, and you get composite score, or even switch between these models. For deployment, you can use the Python model, which is stored in your application, right? And however you want to package it, or you can have multiple models running at the same time. So this will allow you to use different models for different setups. And if you want to scale it, obviously it depends how many clusters you want to define or how many nodes for each cluster you can replicate it. There are 3 ways to deploy it in real time. So first is on host. So this is what I'm doing today here. So I will run it locally. So my node will have the model running in the same on the same machine, or you can deploy it on the edge. So this is basically as close as possible. In most applications, you see it online. They have something called farm setup. So farm setup, essentially, you have all models stored somewhere, and then you have infrastructure. Depends if you use one replication or not. maybe multiple data centers, and so on. So looking at the demo here, if I'm using my card now, and I'm in London, and after 2 hours I use the same card in Frankfurt, in 2 hours time it should validate, at least, because that's how long it takes to fly between two cities. Now if I want to repeat the same process again between London and New York, it becomes really easy to say this is a fraud activity, it should be declined. So I had this slide on one of my presentations. Someone asked, okay, that's easy to develop, so there's no problem here. Why it is important? So it's just a single transaction in isolation. So I had to go back and figure out the answer for that question. So this data is how many flights you see. So for example, if I'm using my card at the airport, so I took average from last year. Obviously, we're looking at the black line. So on average, we have roughly around 250K flights per week. And now we want to multiply it by number of passengers and then by number of cards. So it becomes really huge to process. So this is where we want to be able to scale up and down and provide. And remember, we're talking about 50 or 40 or 60 milliseconds in order to provide the answer. So the setup here, so what you need basically, or what I'm doing is I'm just using the jar file to do it. So I'm running it locally on my machine, one cluster, and then I'm using Kafka to generate the data. I will show you the difference between normal Kafka processing and the real-time stream processing. And essentially, we look at here how we can enrich it. So this is kind of like, because you know Kafka, I don't want to spend time on it. And the setup, as you see it here, we have the transactions coming into your application or my application. I'm ingesting the data, and from there, what I'm doing is, in first step, I'm processing this data. And obviously, I don't know at this step if it is a fraud activity or not. And I want to do some kind of data enrichment. So I'm using SQL to do it, but obviously you can use Java, for example, or Python. And at the same time, once we have the enrichment, we should be able to provide this type of answer, whether it's a fraud or not. So let me jump quickly to the screen here. So I just run the Kafka here. So what you see on this screen, so this is the zookeeper here, and this is Kafka server now running. So it's a simple, if you haven't used Kafka before, just download the Kafka. Obviously you need the package, and then run the zookeeper, define topic you want to use, and then run the server. Now let's move to the Java code for it. So I'm using Java I mentioned. So in Java you can use POM file or Gradle, depends what you want. So I'm simply specifying this jar file I want to use. So I'm just simply specifying I want to use Hazelcast. Obviously, because I'm using the stream processing, I can, or I should use the Jet engine. And here I have the publisher. So from the publisher, you can see I'm defining topic, and then I'm creating Kafka producer. This Kafka producer is sending these transactions. So I'm now replicating what's going on with the banks and online payments and so on. And from there, I just do the count. So if I run it now here, so let me increase the size. So now this data is being generated, right? Now I move to my application in order to process it. So here, as you can see, I'm defining pipeline. So pipeline is essentially your application. I'm reading from Kafka source. I know the topic. I'm defining this topic here. And then I'm using Lambda function. So those who work with Java essentially know what Lambda function is. If you're not Java developer, come speak to me afterwards. I can explain Lambda functions here. And essentially, if you have a batch data, Batch data, it means you know how many transactions or events you have in your database. So you can give me the count. From this count, you can iterate, you say, from x tsawi 1 or equal to 1 to n, and then you can process it. For streaming data, that's not the case. But why? Because you don't know how many transactions. So what you can do is defining window on your data. So you define a window. There are a couple of ways to do it. I'm using something called sliding window. So I define window size, and then so basically how many transactions I want to have in my window, and from there I can slide it. So the sliding process can be uh, based on number, or you say I want to have X number, or you can specify time, whatever you want to have the sliding mechanism, and then it will move in order to process it. So this is the window, and then simply I'm aggregating. So I'm saying how many transactions I have per second. Obviously, I'm sending this data into a logger so we can see results. By the way, someone asked me last time also why I have sleep. It's just because I want you to see your results. Usually, you don't have 20 milliseconds a delay in the application. And then once you define pipeline, you can attach it as a job to Hazelcast instant. So if I run this application now, so if you look at the results here, you can see I'm receiving events per second. So it changes. So 10, 6, 5, 3, and so on. So this is how many transactions your application is receiving in 1 second. So that's the normal way of doing stream processing. So you do some kind of function. So it doesn't have to be counting. It could be machine learning model on top of it. But what does it mean? Does it mean anything, to be honest? I don't think so. Even if it has the fraud model integrated with it, you still need to add context. You still need to enrich it. So even if your model, for example, specify that you have 9 transactions per second and then 1 transaction out of this 9 is a fraud, we need to still know why it happened. So let's move quickly how we can do it in Hazelcast. So I will just change the screen slightly here. And I just say I want to run the Hazelcast instance. So I already started it before starting this session. As you can see here, you should be able to see where Hazelcast is running. So you define member, and then it has a port running. And from this screen, I want to use the SQL. So I have Hazelcast running on my machine. So I just need to use the Hazelcast SQL to do the enrichment. So if I just saved it somewhere here. So I use the Hazelcast client SQL. So I'm just logging into the SQL interface. So once you logged into the SQL interface, you should be able to write SQL commands. And this is very important because it means you can check or monitor or even process in real time if you don't want to write application, to do some kind of filtering. So SQL commands is handy. So in here I have 9 users, whatever, and then I'm simply generating this data. You've seen it in Java. So I'm creating a view based on the data I want to generate, and the generate stream will generate this data for me. So I'm just going to copy this command and paste it. So I'm specifying for each user how to, I think I got it wrong here. So okay, so it's fine. So here I'm generating the data, but it just cut on the screen. Then now I have data, and this data is not stored in database. It's currently in memory. So if I want to do a query, for example, I can do so here. So from here, I start to see orders coming. And obviously, if I want to do filtering for a specific user. I can specify the customer, so I'm just specifying myself. So these transactions coming from this exact user. So it has amount, and then it has also quantity or score attached to it. I just wanted to show you what is possible. Obviously, you can play around with the model, so you can change it. Now, this is fine, but if I want to enrich this data, and keep in mind this data is not stored in database, what I can do is move towards the enrichment. So for enrichment, or before doing the enrichment, I just wanted to show you also you can do any SQL command. So it doesn't have to be only user. You can have a conditions applied. So this is where you can say I want to have a credit score of X. So if it is above 50, it should be passed. If it is less than 50, flag it, whatever the value. And here we can do the enrichment. So for enrichment, what I'm doing is I'm creating extra features. So extra features could be related to any feature for fraud detection. So obviously you need to determine. In my case, I'm defining like red, green, blue, simply because I want just to check the red and flag it as fraud activity. You can use GPS coordinates, or like I mentioned, transaction history or credit history, or even like, for example, your physical address. It could be any combination here. So, and here I'm giving you the option to add 3 features. And if I put it into memory now, this map is like a map structure, so it has key value. If I go back to the slide here, so this is the, where is it? So this is the real-time data, and this is the enrichment. So this is exactly what I'm doing. I'm creating this map, and from there, I'm adding data into it. So this data here, I'm specifying example. So remember, this should be limited because it's stored, it's batch data. And batch data, you know how many transactions you have, or how many events, or how many records stored in your database. In my case, I'm using like blue, red, and green as features to detect if I have a fraud activity or not. So now I simply insert it into memory, into this map structure. Now, if I want to do the enrichment, so the enrichment now will actually read from 2 different databases, or 2 different map structures. So first is the events that you've seen it before, and then the enrichment. So the enrichment part, if I do this select, it will have a SQL running on 2 different map structures, and I'm specifically specifying I want the second features to be red. So that's where my fraud activity is. And if I run this command, now suddenly you see the previous command, the first command I ran, and the fraud activities flagged here. So if you look at the 4th column, so that's the extra 2 feature, you can see I'm just saying I want to check where the fraud activity is. And simply once you have it, you can process and decline these transactions. Now, this is part of enrichment, is good. There is advanced topic for it, so I'm not going to go into it in more details, but essentially, in some cases, even if you ingest your data and enrich it, which is what we're talking about today, you still need to do some kind of stream joining. So stream joining, essentially, if you heard of Open Bank, for example, or if you have multiple banks, which what is going on at this moment, you usually need streams coming from not only from your account and your context, but also related to other factors. So in that case, not only the streaming data as well as the historical data are needed, but also other streams as well, which are not related to your application. So this is streaming, which allows you to actually specify how you want to join two different streams. So in this moment, if you have two banks that are using different algorithms, and then bank A has output 1 or topic 1, and bank B has topic 2, or you can do combination in order to do advanced. So the way to do it is to take this map, and from there you check how much data you want and what is the time window. So you should define descriptor for it. And obviously, because it's streaming data, you need to define window. And from the window, you can, I don't know, you can do some kind of filtering on these joint streams. So you can specify max value and low value. And then you can specify the interval, you can specify the interval on this data. And from there, once you have the map for this joint streams, you can do select. So in this select, the difference between this select and previous one, the previous one is between two maps, whereas this one is between two streams. So it's kind of like advanced for this type of stream processing applications. So, but again, it's just one case if you want to, make advanced feature to the fraud detection algorithm. So with that being said, let's just go back again. I just have one slide here. So we have a community Slack. If you have any question about fraud activities or stream processing or your real-time machine learning, so you should be able to actually join this community Slack and ask questions. So with that being said, thanks very much for attending, and any questions? Thank you.